This video is on some examples on raising a negative number to a power. And you've just been working with a partner and you've been looking at what happens when we raise a negative number to a power. And we're talking about any power. So if I raise it to the power of 100 or raise it to the power of 22 or raise it to the power of 37, what's going to happen to this number? I certainly don't want to write the number out 37 times if I'm raising to the power of 37. So there were some patterns that hopefully you saw, and now we're going to talk about how to use your new knowledge. So here are some examples, and it's around this point that I'd actually like you to pause the video and have a think of a question that I'm about to ask you, and that is, are these two questions the same? Okay, they look similar. How about these two questions? Are they the same? If you think they're the same, that's great. If you think they're not the same, then what's different about them? And finally, well, actually these two you can see, but what's the difference between those two questions? Or even more so, what's the difference between this question and, say, that question? So have the pause of the video and have a good think, and when you're ready to discuss it, or think about, or compare your answer to mine, you can restart the video again. So let's have a look at these first two questions in this first column here. We've got -3, but it's in brackets, okay, and it's being cubed. -3 in brackets being cubed. Over here we have minus and then a 3 and then a cubed sign. So what's being cubed? Well, we don't have brackets around the minus and the 3. And if there are no brackets, then the cubed is really only cubing what is attached to it right before the cube sign. So in this case, we are cubing 3. So we've got 3 cubed with a minus sign in front. That's actually different to this example where it's saying cube everything inside this bracket. This question at the bottom is not saying cube everything inside because there are no brackets, so we don't have to look in. We have nowhere to look inside. What it's saying is cube a number, and in this case, this number is 3. So the brackets are helpful in that they really show you what's being cubed or what's being raised to a certain power. Without the brackets, you really only need to look to whatever is attached to that power to decide what am I raising to that particular power. So before we go through these examples, let's have a talk about what happens when you have many powers. So when you were working with your partner, I'm hoping you came to the conclusions we're about to discuss, and that is when you have two negatives, we know that we can convert our two negatives to a positive. So pairing, every time I pair those two negatives together and say those two negatives, they'll turn into positives. So we've got positives here, oh, but I've got one left over. Positives, 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 and groups of positives. So if you have just positives, any number of positives will remain positive. So that means if you have an even power, so you're going to say you raise something to the power of 40, you're going to have a string of 40 negative signs because you're going to take a negative number and multiply it by itself 40 times over. Well, those 40 negative signs can be broken into groups of two negatives, and all those groups of 2 negatives will turn into positives. So your overall result will be positive. But if you have an odd number of negatives, when you break your negatives into groups of 2, we've got here group of 2, for an odd number of negatives, you'll always be left with one more. So that means you'll have a string of positives, but you'll have one negative at the end. And it doesn't matter how many positives you have, you only need one negative to turn the overall result into a negative. So, like the first example here, I've got one group of 2 negatives, which will make a positive. But as soon as you're left with this one negative here, that'll turn your overall result negative. So when you have an odd number, an odd power, you're going to end up with a certain number of groups of 2 for the negatives, but you'll always be left with one extra. So in this case, we've got 57, which is really 56 plus 1. That's even, so that'll produce pairs of 2 negatives, and then you'll have one, so you'll have negative, negative in a pair, negative, negative in a pair, and so on. And then finally you'll be left with one more negative. So overall, this will be a negative. With the 40, we'll end up, because it's even, we can break it nicely into groups of 2 negatives, making a positive, so we'll end up with positives. Over here, if you think about 99, which is odd, okay, or close to 100, if it was 100, just one under 100, I'd have groups of 2. Or if it was 98, I'd have groups of 2 negatives, which would make positives. But instead, you're going to have negative, 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 and pairs until you end up with one more negative at the end. I'll get rid of that plus. One more negative at the end, and that will make everything negative. So, if we go back here to our first example, we're trying to cube minus 3, and that means I'm going to have 3 negatives. Well, you can think of the 3 negatives and realize that what's going to happen, or you can realize that 3 is an odd number, and if you have an odd number of negatives, you'll get a minus overall. For now, I'm more than happy for you to be thinking minus, minus, minus. Those two make a positive, and then one more minus makes a negative. That's also really good thinking. And then, so we've cubed the negative. 3 negatives make a negative, and then we're going to take the 3 and cube it. So that's 3 times 3, which is 9, times 3, which is 27. Okay. Lose the temptation to do 3 3s. Okay, this is not a number you are multiplying by. That's the power that you're raising 3 to. Now let's see if we get the same answer doing this question. So in this case, we were talking before that we're not going to cube minus 3. We're only cubing 3, and that's because there are no brackets, which means this cubed does not apply to that minus sign there. If there are brackets, it will. If there aren't brackets, it won't. So we know that 3 cubed is 27 because we just found it above. And then that minus, well, there's no operation being performed there with the minus, so we can just drop the minus down. So we do get the same answer. We get minus 27 for both of them. Just because we get the same answer doesn't mean it's the same question. We now can see that in this top example, we did raise the minus over here to the power of 3, but in this second example, we did not really do anything with the minus besides drop it down in the question. Let's see if the same thing happens with this second set of questions. Will we get the same answer? Well, this time around we're squaring, okay, squaring an even number, so we know that we'll end up with a positive, or you can just think, well, I'll have 2 negatives. 2 negatives make a positive. And 5 times 5 is 25. So we must square the negative and the 5, so we get 25 for our answer. Now, if we look at this question below, only the 5 is being squared, okay? The minus is not in a bracket, therefore the squared, that power does not apply to the minus. So I need to square 5, which is 25, and then that minus will drop down. So for this second example, I actually get a different answer for both my questions. So I will not always get the same answer, and that's why you will need to understand the difference between the questions in the top row and the questions in the bottom row. Now, I've just made the third example slightly more complicated. So we've got some brackets, which contain the number minus 2. So I'm going to raise that minus 2 to the power of 4. So this minus is not in the bracket, and that means it is not affected by the power of 4. It will not. So this minus over here will not be raised to the power of 4. And if it won't be raised to the power of 4, I'll just drop it down. And now I'll go and deal with this part of the question. So a minus, I've got a negative and I'm raising it to the power of 4. So that's a negative, 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 negative. Well, each of those groups of 2, we had negative, negative. And then, well, let's clear that out. We had negative, negative, and a negative, negative. So we should have 4 negatives. Well, that first group of 2 will make a positive. The second group of 2 will make a positive. So overall, we get a positive. Or we could think that 4 is even, and so we know that an even number raised, a negative number raised to an even power will be positive. So I don't need to write the plus down because I can write 7 or I can write plus 7, but the plus is not necessary. So we've raised the minus to the power of 4, and finally we're going to take the 2 and raise it to the power of 4. So that's 2 times 2 times 2 times 2. I've got to do it 4 times over. So I've got 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. Every time you times by 2, you are doubling. One more example here. 2 to the 4, so we've got minus, then 2 to the 4. This minus 2 is not in brackets, and that means the power of 4 only applies to the 2, not to the minus. That means I can drop down the minus, and 2 to the 4, like we said before, we've got 2 times 2 times 2 times 2. Okay, you may take your time getting that out. 2 times 2 is 4, times 2 is 8, times 2 is 16. So in this case, we do get the same answer, but as we saw with the middle example, that won't always happen. I do wonder if we could do, might insert a slide. Let's see if you're up for a hard example. So I'm going to write a question. Let's put in a new question. I'm going to give you 2 questions. Let's get rid of this first. Hadn't planned on doing this, but I will now. Alright, first question is going to be minus 2 to the power of 5. And the second question is going to be minus bracket minus 1 to the 17. Okay, I'm going to get you to pause the video, have a think about what you think the answer to those will be. Actually, I might change that. Let's make that slightly different so I know that you understand. Minus 1. There we go. Slightly different question. Okay, pause the video, have a think about both of those, and then when you've got your answers, make sure you commit to an answer, unpause your video, and I'll go through them right now. Alright, so in this first example, we can see that we are raising minus and 2, the minus and the 2 to the power of 5. 5 is odd. Okay, you can visualize what's happening. I've got 1, 2, 3, 4, 5 negative numbers. Those 2 will be positive, those 2 will be positive, and that 5th one will be negative. So we're going to end up with a plus, plus, minus. Any number of positives will remain positive, but all you need is 1 minus to make it minus. So the overall result is a negative. Okay, you could also think, well, it's odd. Odd will result in a negative as long as you understand why. 2 to the power of 5. Well, we just did 2 to the power of 4 in the previous video, and that was 16. Really important to know your powers. If we do 2 to the 5, that's just doubling 16 one more time, which is 32. Okay. The second example, minus 1 not in brackets. That means the 17 only applies to the 1. 1, you can multiply 1 by itself any number of times and it will stay 1. So that's pretty easy arithmetic. 1 to the 17 is 1. This minus, there are no operations being performed with it. It's not being raised to the power of 17. So I will just drop it down and get minus 1. Hopefully you got those both right.